friends, today we discussing about another linear type of data structure which is a queue. In that queue, it is an ordered list of elements in which we can add elements only at one end called rear of the queue and deleted element only at other end called front of the queue. Okay, so here two types of operation. In the stack also we are already discussed that two types of operation is there. One is push and pop. So here the push means we enter the element and pop means we delete the element. Here also we are using these two things, means that adding and deletion. So the adding is here called as rear. At rear end we add this, okay, and another deletion here we are using another end which is called as front. Okay, so here we basically used two ends. One is called front, okay, where the deletion is there. Another is called as rear, where the insertion is taking place. So whenever these two ends are there, okay, so here in which manner we add the elements. Here we add the elements there in the stack. We add the elements and delete the elements. Whenever we add the elements one after another, we add it and delete also one after another. That means in the array implementation, one after next we add it and delete also. But the deletion here is in one end which is called as front, okay, and the deletion order is last in first out order. Okay, so whichever element is here last entered, that element is first deleted. But here in the queue case, so whenever we enter any element 5, 10, 20, 30, 40, so these are these elements we entered one after next. So we delete here from the front end. That means this is your end from where we delete the elements. So whenever we delete the elements from the front end, that means this element is deleted. So this element is first in, first out. So which element is entered here first, we delete that element first. Okay, so it can here first in, first out order here we follow. Okay, suppose whenever it is a ticket queue, for practical example, whenever it is ticket queue or whenever we add any elements, okay, so whenever we add the delete the first element, so the first element which is entered first, that element we here delete it. Okay, so this is the basic thing of the queue. Next, how we insert one after next the element and what is the procedure here we follow it. Okay, so how we deleted that element, how we enter that element. So what are the procedure here we follow for entering each and every element. Okay, so look at this example. Here I am explain about how we enter any element in that queue. Okay, suppose this is a queue. So here we want to enter 5 number of elements. Okay, so the queue name is, suppose name of the queue is here queue underscore ARR. This is the name of the queue. And first, before entering any values, the front equal to -1 and the rear is here equal to -1. So both the values are here. Rear is equal to -1. Okay, that means this is the empty queue. Okay, so what is the empty queue value? Whenever the front equal to -1 and the rear equal to -1, then it is the empty queue. Then after we add another value. Okay, so adding here, adding an element into the queue. So whenever we adding any element into the queue, suppose we add 10 here. Okay, then we enter that 10. So here we enter the 10. So what is the next thing here changed? look at this, the front is previously -1. After entering the value, look at this, the front value is changed 0 and the rear value is also changed to -1 to 0. We adding both these as one value 0 0, but we know that we entering any element in rear end and we delete any element in the front end. That means whenever we enter any element, the rear value is incremented. Whenever we delete any element, the front value is incremented. But for the first case, the front is incremented as well as the rear is incremented. That means here the front and rear both are indicating to this position. Okay. Suppose then we adding another element. So adding another element which is suppose here 20. So we add it 20. Okay. Now next the front value is not here incremented. Okay. So the front value incremented when we delete any element. So now the rear value is incremented, which is from 0 to it is incremented to 1. Okay. So next whenever we add another value which is suppose 30. Okay. So whenever it is 30, so the rear value once again incremented, that rear equal to rear plus 1. So rear is now equal to 2. Okay. Next we enter the 40. So we add another element which is equal to 40. So the rear value is now changed, rear equal to rear plus 1, which is rear equal to 3. Now you add that 50, add equal to 50. So the rear value is changed to rear plus 1, which is now is equal to rear equal to 4. So rear equal to 4. Okay. So whenever we found that the rear equal to max minus 1 and the front equal to 0, that means here the Q is in the full position. Okay. That means from the beginning to the end, whatever be the size is given, all the elements are here. We filled it. Then next the Q is your full Q. Okay. So this is all about the procedure what we follow for that adding any values in the Q. Okay. Suppose we adding the values in the Q and after that we delete 1 and 2 elements. So this is the first element. If we delete it, so the front value now from that 0 it can change from 0 to front is equal to 1. Front is incremented by 1. Front is equal to 1. Okay. Now once again we delete the next element which is here 20. So the front is now equal to 2. Okay. So like this we increment the rear value as well as the front value. Okay. And after whenever the front and rear both are equal to same, that means the total elements are here we deleted. Okay. So then how you write down the program for the add operation in that Q? Then whenever we write down the function, then how we write down this and what is the procedure here we write down? So look at this procedure whenever we write any program. Okay, so what is the procedure here? So first here we write down like this. Here if rear is equal to max minus 1. Okay. So here max means we indicate that the size of maximum is suppose 5 here we are taking. Okay. So if the rear is equal to max minus 1, then printf. So in the program how we write down this? Printf Q is in overflow condition, Q overflow. Next is else. If the Q is not in the overflow, then what we are doing? If front is equal to front is equal to -1. Okay, then we make the front is equal to 0. Okay, then rear equal to rear plus 1. Okay, so whenever rear equal to rear plus 1, that means the rear is here. Now indicating the next position value. Okay, so Q here RA, whatever be the value within the rear, we write down here. So added item, added underscore item, this is the variable. Okay, so we enter it. So how we are doing this? The same thing here. Once again we discuss that suppose from the first we given a defining size of max equal to 5. Okay, so what we are here doing, if rear is equal to max minus 1, so first the rear is equal to here minus 1 and the front is also equal to minus 1. Okay, so both are here minus 1. So if the rear is equal to max minus 1, that means this if condition is not satisfied. Okay, so we go to the else condition. In the else condition, if front is equal to minus 1, yes, the front is equal to minus 1. So what we are doing, we make the front is equal to 0. So then we convert that front and make it as 0. So here we written that front is equal to 0. Okay, then what we are doing? We change the rear equal to rear plus 1. So previously what is the rear value? It is minus 1. So we change the rear value as it is rear equal to rear plus 1, which is 0. Okay, so QRA rear, that means now in the rear position it is 0. So QRA is the name of the array. Okay, we already written that QRA is the name of the array. So here in the 0th position we store the value of whatever with the added value. Suppose we add here 10. Okay, if this is the added value, add here 10. So we insert here 10. Okay, then next, suppose we want to add another value, add equal to 20. Then what we are doing? If rear is equal to max minus 1, now the rear value is 0. It is not max minus 1. So the overflow condition is not happened here. Okay. Else, if front is equal to minus 1, so this thing is here also not happened. If this thing is not happened, so after this front is equal to 0 it is written, so we are not executing this thing. But in that else all these things are executed. The if is not satisfied means this here next line is not executed, but the rear equal to rear plus 1. Okay, so once again we write down the rear is incremented by rear plus 1, but not the front, because this if is not executed. So rear equal to rear plus 1, which is 1. Okay, so next whenever it is 1 we adding that 20, so 20 is added here. Okay, so once again if we want to add 30, if we want to add 40, if we want to add to 50, so once again this is incremented, so the rear is incremented to here. Now it is 2, so the rear equal to 2 here, rear equal to 2. So whenever it is 40, so the rear is changed the value, the rear equal to here, rear equal to here 3. Okay, so whenever it is 50, the rear is here changed, the rear equal to now rear equal to here 4. Okay, the maximum size given here is 5. So we know that here if rear is equal to max minus 1, so max is now 5, max minus 1 is 4, that means 4. Printf q overflow. Now the here all the elements are inserted. Okay, so we find out the rear position is equal to 4. Okay, that means we are getting the maximum value. Okay, so we are next not inserted any elements because it can execute the overflow condition. Okay, so the else part is not executed because the if part is executed. Okay, suppose we delete these elements, okay, these two elements. Okay, so the front value is here changed from 0 to 1. Okay, so the front is incremented and it is changed to 0 to 1, and here the front is now indicating the next position. It is changed from 1 to 2 for deleting this element front equal to 2. But the max position here is same as that of the 5 and the rear position is that of the here 4. Okay, so in this case we are inserting the next element. If this is the case, it is not possible. Why it is not possible? Because already the rear is in which position? Rear is in the maximum position. Okay, so this is the disadvantage of the linear queue whenever we one after another push next elements. Okay, so how we here remove this type of suppose this type of cases are there, so how we just remove this type of error? We are using another concept which is called as circular queue. Okay, so now we are discussing about that adding operation. Then in the next video I am discussing about the deletion operation of the queue. Then after we discuss another program for both that adding and deletion we are using in that program, and we display it. After that we discussing about that circular queue. Thank you.